Chapter 1, Section 6, solving absolute value equations. Raise your hand if you can tell me what an absolute value means.
It's the distance from a number to like 0.
Very good. Remember, it's a distance a number is from 0. Oops.
Learn that in geometry.
So if I ask you to find the absolute value of 8, what is the distance that 8 is from 0? 8 units. What if I ask you to find the distance of negative 8 from 0? 8. Hopefully you guys all remember, but an absolute value just makes a number positive because it is distance. I've used this example before, but I drive a mile to work every single day, right? When I drive home, am I driving a negative mile? No, I'm just driving another mile, right? So distance isn't negative, distance is always positive. So our absolute values cannot be negative. So if I give you absolute value of x equals 3, what values of x would make this equation true? What? X equals 3. Very good. Any others? Negative 3. So there's two answers for this equation, right? If I plug 3 in, I get the absolute value of 3, which is 3. If I plug negative 3 in, I get the absolute value of negative 3, which is 3 equals 3. Right? Everyone agree with those two x values make my equation true? Okay, we need to keep this in mind for today as we're solving our absolute value equations. We've got to account for our positive value as well as our negative value. So a lot of the times when we have absolute value, we're going to have two answers. We're going to see times where there's only one answer or no answers, but a lot of the times there's two answers. Okay? This next slide you don't necessarily have to write down. It is really kind of small. I'll try to write the important things a little bigger, and it is straight from your textbook if you want to look at it in your textbook. Okay? I just want to talk about it a little bit. So, it's pretty straightforward. An absolute value equation is an equation that contains an absolute value expression. Pretty straightforward, right? You can solve these types of equations by solving two related linear equations. One accounting for the positive value, one accounting for the negative value. So let's look at these four properties of absolute values. It says let A and B be real numbers, then the following properties are true. If I take the absolute value of a number, so the absolute value of A, it's going to give me a number that is greater than or equal to 0. What kind of numbers are greater than 0? Positive, right? All positive numbers are greater than 0. So 4 would be an example of a number that's greater than 0. It's a positive 4, right?
Yeah.
What numbers are less than 0? Negative numbers. So when I say the absolute value of A is greater than or equal to 0, it means if I take the absolute value of something, it's going to be 0 or some positive number. Okay? Number 2, if I take the absolute value of a negative number, I'm going to get the same exact answer as if I take the absolute value of that same number but being a positive. So the absolute value of negative A equals the absolute value of A. Does that make sense? We all know that the absolute value makes it positive, right? Number 3, absolute value of A times B equals the absolute value of A times the absolute value of B. So if I have two things being multiplied inside an absolute value, I can split them up into their own absolute values and multiply. Okay? Same thing with division. Absolute value of A divided by B is the same thing as the absolute value of A over the absolute value of B. In this case, we have to say that B does not equal 0 because I can't have 0 in the denominator of a fraction. Are there any questions about any of those properties? Okay. This bottom part down here is mainly what we're talking about today. To solve the absolute value of AX plus B equals C when C is greater than or equal to 0. So that's saying C needs to be what? Greater than 0, so it needs to be a what kind of number? Positive or 0 itself. So when C is greater than or equal to 0, I need to solve the related linear equations. AX plus B equals C, as well as AX plus B equals negative C. I have to have two equations. One accounting for the positive value, one accounting for the negative. You guys remember me saying that multiple times so far. We got to account for the positive value as well as the negative value. What do you notice about this equation and this equation? Are there any similarities between them?
Yeah. They get the same answer.
I'm just talking about the looks of them right now, not answer-wise or anything like that.
They have the same variables.
They have the same variables. Are they almost exactly the same?
Yeah.
What's different about them?
The
Absolute value bars, right? So my first equation that I set up will always be the exact same as my original equation, just without the bars. Okay? My second equation will look very, very, very similar. I just have to make my C value negative. And that's my two equations that I set up to solve. And that's how I'm solving my absolute value equations. We are going to see examples, so hopefully it'll make a little more sense once we get to them. Okay? The last paragraph says when C is less than 0, what numbers are less than 0? Negatives. So when C is negative, the absolute value equation, absolute value of AX plus B equals C, has no solution. Can my absolute value be negative? No. It's distance, remember? So if my C value is negative, I have no solution because my absolute value can't be negative. Does that make sense? Any questions about any of this before we jump into our examples? Like I said, it might be a little confusing at first, but I think my other classes started to get the hang of it the more I did examples. Okay? Example 1. Solve each equation. Graph the solutions if possible. Solve each equation. Graph the solutions if possible. So letter A, I have the absolute value of x minus 4 equals 6. Absolute value of x minus 4 equals 6. So which of these numbers is my C value based on this equation right here? Does everyone see how my C value is 6? Absolute value of AX plus B equals C. My C value is just the number on the right side of the equation. Okay? Is my C value, is it greater than or equal to 0? Or is it less than 0? Greater than or equal to 0. It's a positive number, right? So since it's positive, I can set up my two equations. What do we say about our first equation? It's going to be the exact same as this, just without the bars, right? So based on this equation, what's my first equation going to look like?
X minus 4 equals 6.
Very good. There's my first equation. Exactly the same as my original, just without the absolute value bars. Everyone got that? What do we say about my second equation? What's different about the second equation from the first equation?
C is negative.
I just changed my C to negative, right? So what's my second equation going to look like in this case?
X minus 4 equals negative 6.
Very good. X minus 4 equals negative 6. There's my two equations that I'm solving to get my answers for this absolute value in an absolute value equation. Because I'm accounting for the positive value as well as the negative value. Does everyone see that? Now I'm just solving these two equations. What's my one and only step to get x by itself on both equations?
Add 4.
Add 4 to both sides. On both equations. First equation, what is 6 plus 4? What? 10. There's one of my solutions. Second equation, what's negative 6 plus 4?
Negative 2.
Negative 2. There is my second solution. Any questions about how I got my solutions? Once again, if you want to check your answer, you can always plug these back into your original equation. So if I plug 10 in for x, what's 10 minus 4? 6. And then what's the absolute value of 6? 6. Does 6 equal 6? Yes, it does. It checks out. Plug negative 2 in. What's negative 2 minus 4?
Negative 6.
Negative 6. What's the absolute value of negative 6?
6.
6. Does 6 equal 6? Yes, it does, so it checks out. Does everyone understand the process we went through to get to our answers? Coming up with two equations. One accounting for the positive value, one accounting for the negative value. Am I done with this problem, though? What does it tell me to do? Not check it. Graph it. So I'm just going to draw a number line. What's my first solution?
10.
10. So I'm going to put a point at 10 on my number line. What's my second solution?
Negative 2.
Negative 2. So I'm going to put a point at negative 2 on my number line. And there's me graphing my solutions. Any questions there? Any questions about how I got either of my answers or how I graphed it?
How you graphed it?
So I just put a point on the number line of each of my answers. So x equals 10, put a point at 10 on my number line. X equals negative 2, I put a point at negative 2. We good? Can I erase and move to B? Okay, raise your hand if you think you can help me out with B. Yes. Yep, just walk me through it.
So, for the first one, you just, it's positive, so it would just be 3x plus 1 equals negative, what? I guess, you can't do that,
What do you mean I can't do it?
because it's less than 0.
Very good. Look at our C value. What's our C value in this case? Negative 5. Is negative 5 greater than or equal to 0 or less than 0? Less than 0. What's my answer if my C value is less than 0? No solution. Does everyone see that for letter B? What this equation is telling me is that my absolute value equals a negative number. Can my absolute value be negative? No. No matter what number I plug in here, it's going to turn out to be positive because of my absolute value, right? I'm going to do all the stuff inside the absolute value, and then I'm going to take the absolute value, which will give me a positive number, right? So no matter what number I plug in, it's going to turn out to be a positive number, so it can't be negative 5. Does that make sense for letter B? Why I got no solution? Okay, can I move on? All right. All right, knowing that information, let's look at example 2. Solve the absolute value of 3x plus 9 minus 10 equals negative 4. Raise your hand if you can help me out here. Yes. Mm-hmm.
The C value or whatever is -4, so it's no solution.
How many of you agree with no solution? How many of you disagree with no solution? I disagree.
Why?
Here we go. It is not no solution. Let's look at it real quick. On letter B right here, do I have anything being multiplied by my absolute value? No. Do I have anything being divided by my absolute value? Do I have anything being added to it? Do I have anything being subtracted from it? No. Same thing on my first slide. The equation I'm looking at is the absolute value of ax plus b equals c. There's nothing being multiplied, divided by, added to, or subtracted from my absolute value, right? So the very, very, very first thing I need to do when solving absolute value equations is to check and make sure my absolute value is completely by itself. Is my absolute value by itself in this case? What's with it? The minus 10, right? So how would I get rid of a minus 10 with it? Add 10 to both sides.
I was just trying to help you help them.
Thank you. So I get the absolute value of 3x plus 9 equals, what's -4 plus 10? 6. Now, is my absolute value completely by itself? Yes, it is. Now, is my c value greater than or equal to 0 or less than 0? Greater than or equal to. So does that mean I can set up my two equations, or is it no solution? If it's greater than or equal to 0, I can set up my two equations. Does everyone understand that? Make sure the absolute value is completely by itself first. Then look at C. Raise your hand if you can give me my first equation. Yes.
3x plus 9 equals 4. Or 6, sorry.
3x plus 9 equals 6. Once again, it's exactly the same as the original, just without the bars. Someone new who hasn't talked today, raise your hand and give me my second equation.
3x plus 9 equals -6.
Very good. 3x plus 9 equals -6. It's exactly the same as my first equation. I just make the c value negative. Everyone with me so far? Okay, what's my first step on both equations to get x by itself?
Minus 9.
Subtract 9 from both sides. So for the first one, what's 6 minus 9? -3. For the second one, what's -6 minus 9?
-15.
-15. Any questions with what I've done so far? We all understanding? Last step on both equations. Divide by 3 on both sides. Still got to get x by itself. First equation. What is -3 divided by 3? -1. Second equation. What's -15 divided by 3? -5. So my two solutions are -1 and -5. If I plug those back into my original problem, I should get a true statement. Does it tell me to check my solution? No. Does it tell me to graph my solution? No, so I'm done with this problem. Questions on it? Is it a little better than when we first started talking about it?
Yes.
Good. Okay, extraneous solutions. When you solve an absolute value equation, it is possible for a solution to be what we call extraneous. An extraneous solution is an apparent solution that must be rejected because it does not satisfy the original equation. So, I solved my equation. It looks like I got two answers. Oh, everything's fine and dandy. But then I plug it in and it doesn't work for my equation. If it doesn't work for my equation, I got to reject it because it's not a solution. I only accept solutions that make my equation true. Okay? Does that make sense? So let's look at an example. Solve the absolute value of 2x plus 12 equals 4x. Check your solutions. So let's ask ourselves, is my absolute value completely by itself?
No. Yes.
Yes, it is. Nothing's being multiplied by it, is it?
No.
Nothing's being divided by it, is it? Nothing's being added to it? Nothing's being subtracted to it, right? So it is completely by itself. Is my C value greater than or equal to 0 or less than 0?
Well,
Well, we don't know, do we?
yeah.
We don't know what x is. So let's just treat it like it's greater than or equal to 0, and let's create two equations, okay? So what would my first equation be?
2x plus 12 equals 4.
2x plus 12 equals 4x. Exactly the same without the bars. What would my second equation look like?
2x plus 12 equals negative 4x.
2x plus 12 equals negative 4x. Just like the first one, my C value is just negative now. Everyone still with me? Okay, this kind of ties in yesterday's lesson. I've got a variable on both sides, right? So we got to go through our steps of solving an equation with a variable on both sides. Can I simplify either side of either equation? Nope, I don't have any like terms. I don't have any distributive property I can use. They're all simplified up, right? Second step, what's my next step when solving equations with variables on on different sides?
Variable on the side.
Collect my variable to one side of the equation. So how am I going to do that here?
Subtract 2x.
Subtract 2x from both sides. So it's a positive 2x, so I have to subtract it on both equations. So left equation, I get 12 equals, what's 4x minus 2x?
2x.
2x. Right equation, I get 12 equals, what's negative 4x minus 2x?
Negative 6x.
Am I moving too fast for anybody? I can slow down if I need to. Okay, left equation. How do I get x by itself?
Divide by 2.
Divide by 2. So x equals
12. 6.
6.
Oh, 6. Sorry.
There's one of my solutions. Maybe. Right equation, how do I get x by itself?
2. Oh. Divide by negative 6.
Divide by negative 6. So x equals
Negative 2.
negative 2. There might be another solution right there. Questions how I got to x equals 6, x equals negative 2. Okay, what does it tell me to do next?
Check solution.
Check my solutions. Can I erase my work up top so I can have room to check? So I'm just plugging 6 in first. Plug it in for both of my x's up there. Now I'm working inside the absolute value. I'm using my order of operations in there. What's 2 times 6? 12. 4 times 6?
24.
24. 12 plus 12?
24.
24. And absolute value of 24?
24.
24. So when I plug 6 in, do I get a true or false statement? True. That's a true statement, right? 24 equals 24. So is 6 a solution or an extraneous solution?
Solution.
It's a solution. It works for my equation. Now, that does not automatically mean that negative 2 is an extraneous solution. I still have to check it. It still could be a regular solution. So I have to check it as well. Plug it in. For both x's. 2 times negative 2? Negative 4. 4 times negative 2?
Negative
Negative 8. Negative 4 plus 12.
8.
And absolute value of 8. 8. When I plug negative 2 in, does it give me a true or false statement? False. 8 does not equal negative 8, does it? So, this is an extraneous solution. I have to reject it as a normal solution. Does everyone see why? Because it does not work for my equation. Yes?
Okay, I don't want to sound really dumb here, but you, like, on the second equation, don't we have to change the 4 to negative 4?
No. This is me checking my solution. So I'm not changing any signs. I'm just plugging in and working down both sides of the equation. Does that make sense? So for the left side over here, I just plugged in 6, and now I'm working down both sides. Here, I plug in negative 2, and I'm just working down both sides. Okay? I'm not trying to solve my absolute value equation because I already solved it. I'm just checking my work now. Does that make sense?
Yeah.
Okay. Questions on this last example? Any questions about any of the notes we just took? We all right? We ready for the assignment? Yeah, y'all are excited for the assignment. Page 42. 2 through 24, evens. So we do Thursday, September 2nd on Canvas. Tomorrow is September 1st. Wow. It's crazy. September already.
September, wait, what?
Today's August 31st. Are there any questions before I end my recording? Make sure you get this written down. Make sure you get the correct heading on your paper. Name, date, period, assignment, upper right-hand corner. I'm ending the recording now.